Okay, this is just a podcast over what you need to study for the test. You will not get any new information out of this podcast. I will review a little bit of stuff, but other than that, this should just be what you can expect on the test. So first of all, the test is 120 points. That's a lot, but we've done a lot of naming. Okay? In this test, the first 60 are all in groups of 10. Okay? So there'll be 10 elements. In 5 of those, you are going to write formulas from the name. So I give you the name, and then you write the formula. And then in those groups 5, I'll give you the names, and you write the formula. Okay, and so that's what I mean by groups of 10. Now, these first 60 are all grouped by the category that they are in. Okay, and I'll give you an example. Okay, the first group, okay, and it might not necessarily be the first group on the worksheet, but one of the first things we did was just plain old binary compounds. Okay, and these binary compounds are going to be without transition elements. So if you go back and look at one of the very first worksheets that we did, okay, you can see this, and you can kind of review these. So by what I mean by they have formulas, and you're going to write the name. There's literally going to be 5, just like this one, where there's 5 formulas that are written out, and you're going to name them. Now, the one thing I want you to notice is right alongside of those, there's going to be 5 names. So use the names to help you with writing the name, and then use the formulas to help you with naming them, because that's going to, they're similar in their structure. Okay, so the way I would do this then is this first one, the name of this will be calcium nitride. Okay, notice there are no transition elements, so this group will have no Roman numerals in it. And then when I write barium phosphide, it's got the IDE ending, so barium is +2, I look on my sheet, phosphorus is -3, so this will be Ba3P2. And you'll do that for those. That's the first one. Okay? Now, these are all group 1 or 2 elements, at least as far as the metals go. Okay? And they'll also include silver, cadmium, zinc, and scandium. Okay? So that's one group. Another group will be with the prefix system. Okay? Now, with the prefix system, okay, that's using di, tri, etc. Okay? And that's also when you have a nonmetal bonded to another nonmetal. So something like xenon with 6 chlorines here, and this would be, oops, I was going to spell that wrong, xenon, and then you need to know the prefix for 6, which you can look on your polyatomic ion sheet. So this would be xenon hexachloride. Okay, because there are 6 of them. Okay, and then deuterium pentoxide would be Te2O5. And remember, with this prefix system, it tells you exactly the number of atoms. Okay, there's no thinking about it. It tells you exactly. I don't have to worry about charge. I don't have to worry about anything. It tells me exactly what the number of atoms are. Okay, so that's second system. Okay, the third system, or the third group, excuse me, is going to be naming with polyatomic ions, but still without transition elements. Okay, so you're going to have polyatomic ions in there, but no transition elements, so I still won't have to worry about charge. So this would be lithium chlorate. And this would be barium phosphate, which would be Ba3P2. Okay? Now, the fourth grouping is going to be naming using the stock system. Okay? And remember, we're going to use the Roman numerals to help identify the charge of the metal. Okay? So basically you're doing oxidation numbers because this 3 means that this tungsten is +3. So this would be tungsten 3 bromide. And this titanium 4 means that titanium is the +4 charge. And I have a phosphate here, which is a PO4 3 minus. So this gets to be Ti3 parentheses PO4 4. That's an interesting one. Okay, so if you look at this group here, which of these in this group needs to have Roman numerals? Okay. Go ahead and pause the vodcast so you can pick them out. The ones you're looking for are the ones that have more than one charge. Chromium does, sodium doesn't, silver doesn't, iron does, nickel does, palladium does, zinc does not. Tin does, this should be PB, okay, that's lead, but lead does. Aluminum does not, strontium does not, copper does, gold does, cadmium no, chloride no, osmium yes, potassium no, sulfur no. Okay? The next group, and we're up to our 5th grouping, are going to be naming using the old system or the classical system. Okay? And this is with the OUS and the IC. Those are on your polyatomic ion sheet as well. Okay? And one of the things that I decided is that I will only use the classical names that are on the polyatomic ion chart. So once you get to this system, everything is right in front of you. You should have no excuse for getting this wrong. Okay, and then the last one is naming, the last one is naming acids. And remember, if you have a binary acid like HF, HCl, HBr, HI, okay? Those are binary acids. That's where you use the prefix hydro and ic. When you have oxyacids, okay, oxyacids all have oxygen in them, HNO3. Okay, you look at the polyatomic ion. The polyatomic ion in this is nitrate. And 8 becomes an ic. So this is nitric acid. Okay? And then, so 8's become an ic, and 8's become an us. Okay, so right down here, this right here is acetate. 8 becomes an ic. So this is acetic acid. Okay? Oh, here's a binary. That binary needs the hydro. So hydro, and then it's fluorine, so fluoric acid, and that's it. Hydrofluoric acid, to put an ic on the end of it. Okay, so those are your acids. Then, once you're done with those 25, or those 60, you will have a group of 25 formulas where you're going to write the name, and you're going to have 25 names where you're going to write the formula. These are all the categories mixed together. Now I want to know, can you go through and pick those out? Okay, the next thing on the test are 5 oxidation numbers, which quite honestly you've been doing throughout the test, so I really didn't need to put separate on there, but I want to see if you can. And then I have 5 formulas, then you're going to tell me what's wrong with the way it's written. Okay? So, as an example, I have NaS written, and I called it sodium sulfide. Okay? What's wrong? Okay? Is the formula wrong, or is the name wrong? How should I change it? And what you should be able to pick out is sulfide is a -2, sodium is a +1. This formula needs a 2. Okay? Potassium sulfate here, or K2SO4, I call potassium sulfide. What's wrong with that? Well, what's wrong with that is SO4 is not sulfide, SO4 is sulfate. So this should be potassium sulfate, not potassium sulfide. Okay? And then in this formula, okay, it's magnesium carbonate. Well, there's nothing wrong with that. Okay? This magnesium, that's carbonate, so that seems okay. And magnesium doesn't require a Roman numeral, so I don't need to put a Roman numeral here. Okay? So what's wrong with it? Well, what's wrong is Mg is a +2, CO3 is a -2, so I just need to write this as MgCO3. So I'm going to have 5 on the test where you have to pick out what's wrong. Okay? Now, I'm just going to do a little review here, and if you want to fast forward, go ahead, but you should look at some of these as we go. Okay? So what do the following stock system numbers mean in the names? Hopefully we know this by now, that that's the charge of the metal. So this is Ta plus 5. So the formula here would be TaCl5. Gold, and by the way, people are mixing up gold and silver. Gold is Au. So this is gold plus 3. With a phosphide, which is a -3. So that would be AuP. Zirconium 4 would be Zr plus 4. Carbonate, CO3 minus 2. Okay, so I'm obviously going to need 2 CO3 minus 2s to match up to that plus 4. So, Zr, that's bad. So this is going to be Zr parentheses CO3 close the parentheses 2. And technetium 7. Now we haven't had one that big, but that would be Tc plus 7. And that really would, and nitrate is a -1. So you would have TCNO3 7. Okay? Now, this top section here, can you answer the question? Why do we only use prefixes on these? Why do each of these just get prefixes in the name? And that is because it's a non-metal to a non-metal. Okay? That is why. So, if you want to pause the vodcast and take a moment and name these, that would be a good idea. I'm just going to write the names out right now. You can even name them in your head right before I do. This first one is sulfur tribromide. The second one is dinitrogen. Tetrachloride or tetracarbide. That's carbide, sorry about that. Okay, this one here is tribromine pentsulfide. Okay, this one, triphosphorus pentiodide. This one, diselenium trioxide. Okay. One thing to notice is, notice the first name doesn't change because it's now the positive. We are always used to sulfur being a -2. In this case, sulfur is a +3 charge. The bromine is a -1. Okay. Dinitrogen. Again, notice we did not say dinitride. Okay. There's no IDE ending here because it's a positive charge. But this does have an IDE. No IDE ending? Yes, IDE ending. Okay, so I have a group down here, group of elements. Can you pick out which one of these would need to use prefixes? Again, pause the podcast and pick them out. I'm just going to circle them now. That's it. Okay? metal, 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 metal. So if you're a metal, you do not use prefixes. Okay, and then in the old system, okay, make sure you understand what the charges are. Cu plus 2, higher charge, cupric. Ic is the higher charge. Ni, nitric, or excuse me, not nitric, nicolic. Okay, Sn, stannous, lower charge, and Pb, higher charge. Again, use polyatomic ion sheet. Okay, and I think this took me a lot longer than I was going to, but you must study. Do not come into this test thinking you understand everything, because remember, if you get 75% or below, you will retake this test, and it will be 120 different elements when you do that. You will not retake the same exact test. You will get 120 brand new different compounds. And if you fail that, then you do it again. Okay? You do not move on until you pass the test. You keep falling further and further behind, you will be failing at midterm. Okay, that's all I got.